A visionary research mission. GeoLaB takes off and heads underground. Scientists searching for a suitable site for a research laboratory up to 400 meters below the Earth's surface. The aim of GeoLaB? To study deep geothermal energy in greater detail. A particularly large share of this energy is stored in crystalline rock, such as granite. Here lies an inexhaustible and so far barely tapped reservoir of geothermal heat. Bastian Rudolph is project leader of GeoLaB at Karlsruhe Institute of Technology. He's part of this pioneering joint effort.
There is nothing comparable in Germany. An underground laboratory for geothermal research simply doesn't exist, and such a lab where we can conduct targeted experiments to build a fundamental understanding of geothermal energy is exactly what we need.
To prepare for this, the GeoLaB team uses a range of investigative methods, such as aeromagnetics. Crystalline rock underground has different magnetic properties. These alter the Earth's magnetic field, and that can be measured. TU Darmstadt is researching every aspect concerning groundwater. In addition, the GeoLaB team carries out specialist drillings and seismic measurements using vibration trucks. This way, they decipher the structures beneath the surface. Even now, geothermal energy could supply 25% of our heating needs. In the future, it could be far more. Geothermal energy is a clean domestic energy source for our households, and it has another major advantage.
Geothermal energy is baseload capable. Even on a calm, windless night, it can generate power for everyone.
For its research site, the GeoLaB team has chosen the Tromm in the Odenwald region of Hesse. An area where granite rock can be studied particularly well. Here it actually reaches the surface. To gain a more detailed view inside the Tromm, the researchers carried out 2 exploratory drillings. In the first drilling, a continuous core of crystalline rock was recovered along the full length for lab analysis. The material weighs almost 12 tons, about the same as 7 cars. The second drilling had a special feature. From the start, the engineers deliberately inclined it sideways, reaching more than 300 meters away. With this so-called deviated drilling, the GeoLaB team can investigate the rock on a much larger scale. This produces an even more precise picture of the Tromm, including images from several hundred meters underground. Engineer Said Kamrani from Helmholtz Center for Geosciences worked long shifts on site. He has led many drillings, but this one was new to him too.
To reach 300 meters sideways at 500 meters depth in granite is something special, and for me, a challenge I was happy to take on.
To meet this challenge, the GeoLaB team had to plan carefully in advance. The goal? To save both time and money through flawless engineering. And indeed, the drilling team finished significantly earlier than planned, a rarity in projects of this scale.
We've managed to make such rapid progress because everyone worked together. A healthy mix of expertise, enthusiasm and teamwork.
If it turns out that the Tromm is geologically suitable for research, the next step follows. The GeoLaB team plans a horizontal tunnel 1 to 2 kilometers long into the mountain.
At the end of this tunnel, we'll enlarge galleries, and there we'll conduct our experiments.
It is not yet set in stone whether the Tromm will be suitable. But if the underground laboratory goes ahead, it will be a unique research site. The GeoLaB team will be able to study how water flows through fine fractures in crystalline rock and the processes that occur there. because warm water underground transports deep geothermal heat upwards. With the insights gained, science can develop the right technologies to harness deep geothermal energy safely and efficiently. The region around the Tromm will play a key role in helping to achieve the energy transition. An investment in a sustainable future for us all, and a perfect landing for fundamental research.